Way to go, chemistry students. We are up to module number 5. In module number 5, we are going to be learning how to count the molecules and atoms in chemical equations, as well as learning how to predict the products of chemical reactions when given the reactants, or vice versa. The way that we can do this is by knowing the 3 basic types of chemical reactions. The first type is one that we have already talked about, decomposition. A decomposition reaction is one that changes a compound into its constituent elements, or the elements that it is made up of. So you're starting with a compound and you are splitting it into its constituent elements. Okay? Here's an example. 2H2O yields 2H2 and O2. Okay, so if we were just given water and we were told what is the decomposition reaction for water, we would be able to predict the products just by splitting it up into hydrogen atoms, actually hydrogen molecules since it's a homonuclear diatomic, and oxygen molecules. So you just split them apart and then you balance the equation. So here are the steps to predict and balance. Number 1, we are going to look at chemical formula of compound. Look at the chemical formula of the compound. All right, step 2 is you split it up into its individual elements. Split into individual elements, and remember any homonuclear diatomics. So I'm going to say remembering homonuclear diatomics, or we can just call them diatomics for short. Okay, so remember how to find that upside down backwards L that I told you about, or it's even better if you think of it as a 7. Don't ask me why I didn't think of it as a 7 the first time that I saw that shape. But you now know where to find them on the periodic table. And lastly, step 3, you balance the equation. Okay, so let's take a look at an example in your book. Example number 5.1, which is on page 134. Write the chemical equation that describes the decomposition of ethanol. Ethanol, the problem shows you, let's see, this is example 5.1. We are going to be decomposing ethanol. All right, the chemical formula for ethanol is C2H6O. So the first step to predict and balance the decomposition of ethanol would be to look at the chemical formula of the compound. Here we have it. And then number 2, split it into the individual elements and remember the diatomics. So once we split this up, we're going to be left over with carbon. Is carbon a diatomic? No, it is not. And we're going to be left over with hydrogen. Is hydrogen a homonuclear diatomic? Yes, it is. So this is not only going to be written as H, it's going to be written as H with a little 2 subscript. And the last element present is oxygen, also a homonuclear diatomic. So it's not just O, it is O2. And lastly, we have to balance the equation. So let's take a look at the carbons first. Carbon on the reactant side has 2. Carbon on the product side has only 1. So we're going to go ahead and switch that right now. What would we need to multiply 1 by in order to get 2? Ding, ding, ding. That's right, a 2. So we put a 2 out front as the coefficient. Okay, so this becomes a 2. Now the carbon is balanced, at least for now. Hydrogen. Hydrogen, there is 6 on the reactant side. Hydrogen has 2 on the product side, but we need it to be 6. So we need to add a coefficient of 3 out front. Multiply that 2 times 3 and we end up with 6 hydrogens on the product side. Now the hydrogen is balanced. Lastly, oxygen. Oxygen, we start with 1 on the reactant side, and on the product side, we have 2. So this time, we have to add a coefficient out front of the oxygen. Now, can we just stick it here in the middle of the formula? Of course not. We have to stick the coefficient in front of the entire molecule that the oxygen is a part of. So the coefficient comes out here. So now we have 2 oxygens. However, we also just changed the amounts of carbon and hydrogen. So now we have 4 carbons. Just keep crossing them off and changes the coefficients. So over here, we need, instead of a 2 coefficient, we need a 4 coefficient so that we have 4 carbons on both sides. Okay? Hydrogen. Now instead of just 6, we have 6 times the coefficient out front. 6 times 2 is 12. We now have 12 hydrogens on the left, so we need 12 hydrogens on the right. So instead of a 3 here, this actually needs to be a 6. Good idea to balance equations with pencils or dry erase markers and a whiteboard. So this is now 12, and our oxygens are still balanced. So now we have the balanced equation for the decomposition of ethanol. Okay, the second basic type of chemical reaction, number 2, is a formation reaction. Now this is basically the opposite of decomposition. Formation is a reaction that starts with 2 or more elements and forms one compound. So an example would be when we are putting 2H2 plus O2 yielding H2O. So we're putting together hydrogen and oxygen and we are forming a water molecule. Okay, so just the opposite of decomposition. Example 5.2 is an example of a formation reaction. On page 138 of your book, it says, write the chemical equation for the formation of MgCO3. Formation of MgCO3. So this time, MgCO3 is our product. We are ending up with a compound. Just like in our example up here, we ended up with the compound of water. So we have to figure out what elements are present, and the elements that are present are going to be our reactants. So first off, we have magnesium plus C for carbon plus O for oxygen. Remember, O is always written as O2. So we have these 3 elements present. They react together and they form MgCO3. So those are our reactants in our products, and now we have to balance it. We'll start with magnesium. Magnesium on the left has 1 atom. Magnesium on the right, 1, because there is no subscript after it. Carbon. Carbon on the left has 1 atom present. Carbon on the right, also no subscript, meaning there's 1 carbon atom. 1. And lastly, oxygen. Oxygen has 2 atoms in this diatomic molecule. And on the right, the product side, oxygen has 3. Okay, so that means we're going to need to increase our amount of oxygen on this side. But we can't do 2 times something equals 3, so there's not really an easy factor to multiply by. So when we have numbers like this, you know you're going to have to change, you're going to have to give a coefficient to both. Okay, so you find the least common multiple. In algebra, you may be used to be able to find least common multiples. The least common multiple of 2 and 3, meaning what could they both be multiplied by number by and get that other number, is 6. 2 can be multiplied by 3 to get 6. 3 can be multiplied by 2 to get 6. So we're going to end up with 6 oxygens on the left, meaning we have to multiply it times 3, so 3 is our coefficient. Okay, so now we have 6 oxygens on the left, and on the right-hand side, 3, we want this to become a 6, so we have to multiply it times 2, so 2 is our coefficient. So 2 has to go out front in front of the whole compound, okay? Now, your book handles this a little differently, and they have you start by adding a fraction as a coefficient in front of the oxygen. You can do it that way too. In fact, you should be able to know how to do it both ways, because sometimes equations are kind of tricky to balance, and so it's good to have 2 ways to come about it. But this is the way that I always do it, is I find the lowest common multiple and go from there. Okay, so now that we've added this 2 out front of our compound, we have messed up the magnesium and the carbon. They are no longer balanced, are they? Because now over on this side, we have 2 magnesiums, but that's an easy fix, because over here, we have 1. To make this a 2, we need to add a 2 coefficient out front over here. Carbon. On the right now, we have a big 2 coefficient, so there are 2 carbons on the right. So in order to get 2 carbons over here, we need to multiply times 2, so 2 is our coefficient in front of the carbon. And now everything is balanced. So we can circle it and say here is the formation reaction for magnesium carbonate. All right, that is all I have time for in this video, so you will need to watch video 5B for the 3rd type of basic chemical reaction, which is going to be combustion.